since these two triangles are similar, I've got, let me call it A, B, and C. I've got this A, B, and C, X, Y, and Z. Since they are similar, I am sure that BC over YZ equals to AB over XY equals to AC over XZ. Can we say that? Yes, we can. Do you know that actually this is also the same as height of the smaller triangle ABC divided by height of the bigger triangle XYZ? Right? Do you know that? Do you really know that? Now you know lah. The height, ratio of height is going to be the same also. Okay? We can draw triangles to convince ourselves. In this case, can you just put on at the bottom, ratio of height equals to 8 to 16, which is the same as 1:2. Okay, so this is something that you need to take note of. 1:2 over here, 1:2 over here. Although it is a ratio of base and then ratio of heights, they're all the same because they're all units of length. Next, what about the ratio of the area? Half times base times height. We can all do that. So the ratio, the area for the smaller triangle, half times 10 times 8, base and height, divided by half times 20 times 16, 20 and 16. What do we get? 1:4. Is it the same as the ratio of the base? Is it the same? They are not the same. Is it the ratio of the height? Is it the same? No, it's not the same. Surprise! They are not the same. Okay? Why aren't they the same? One is length, one is area. So, what makes them different? That's a very good observation. Square centimeters. Does that give you a clue actually? Okay, you go and think about it along that line. But I want to show you something over here. When I have the ratio of area divided by, when I have the area divided by area, you got half base times height, half base times height, right? Can I cancel the half and a half? Of course I can. Cancel them away. Now this 10 and this 20 over here, what is it actually? Ratio of bases, right? 10 to 20. See, they're the same thing. 10 to 20. If I simplify it, I am supposed to get 1:2, isn't it? So by right, I'm supposed to get 1/2 times 8 over 16, right? Then we go on to 8 and 16. 8 and 16 is actually the ratio of the heights, which is actually 1:2 again. Is it a coincidence that it's always 1:2? No. Why are they always 1:2? Because they are similar figures. The ratio must be the same. Okay, so this 8 and 16 becomes 1:2. Okay? 1:2 times 1/2. I can rewrite it this way. 1/2 times 1/2. I can rewrite it this way. 1/2 square. What does that give me? Okay? Okay, next one. Let's see. 12 and 18. Ratio of the side will be 12 to 18, which is simply how much? 2 to 3. Agree? Right? I'm right, Ratio of area. Okay, so let me change it to a thinner pen. Ratio of area. I need the area of the small square. How much is it? 12 times 12 divided by 18 times 18. 12 times 12 divided by 18 times 18. Yeah, we can evaluate. It becomes 144 divided by something. How about I change it to become like this? 12 over 18 times 12 over 18. Are they the same thing? Yeah. Okay, I can rewrite this to become 2 over 3 square, right? Which is actually 4 over 9. What do you think I'm trying to tell you over here? If I give it a ratio of length, can you tell me ratio of area? All we need to do is to square it. Let's check again. Next one. Ratio of breadth, 9 to 12. Ratio of breadth will therefore be 3:4. Okay? Now if you want, you can check the ratio of length, if you like. 15 to 20 gives us 3:4 again. Right? Divided by 5. 3:4 again. Ratio of area, 9. So 9 times 15 divided by 12 times 20. I'm not going to work it out because I know it's going to be 9 over 16. You can work it out. You will get 9 over 16. Okay? Yeah, you leave it in ratio. It can be 9 to 16. Okay? Let's try for a circle this time. Ratio of the radius, 15 to 18. That gives me 5:6. What about the ratio of area? It should be pi r squared. 15 squared divided by pi 18 squared. This one is clearer, right? Because all we need to do is to cancel pi and pi. Then I'm left with 15 over 18 squared. So this is 15 over 18 square, which is 5 over 6 square, which is 25 to 36. Okay? With all these examples, I want you to compare this 2 to 3, 4 to 9, 3 to 4, 9 to 16, 5 to 6, 25 to 36. What is the relationship? To move from left to right. Square them. Okay, so let me rewrite it. This should be 4 to 9. And we see that when I have the ratio of the sides, over here, ratio of the side, it can be side, it can be breadth, it can be radius. All these are considered sides. Even if you like, the height, they are all measurements of length. Just length, not area, nothing else. Once I have this ratio, all I need to do is to square it, and I get a ratio of area. Okay? So if I have a shape like this, an octagon, they are similar. The ratio is A to B. Can you tell me the ratio of area? How much is it? A square to B square. Need to calculate? No need to go and calculate area lah. Then divide into how many triangle, find the angle. No need. This is the relationship, A square to B square. Okay? Since we are at this, right, I just extend a little bit. Square. Okay, similar cubes. Yeah, now let's talk about volume. Okay. So my own question, cubes. Are they similar? Yes, cubes are similar to each other. So if I have this as 2, this as 6, let's choose a smaller number, 3. The length over here is 2, the length over here is 3. What is the ratio of sides? Ratio of sides is 2:3, right? What is the ratio of volume? 2? 3 cube. Yeah, you're right. Ratio of volume equals to 2 cube to 3 cube, for the same reason that we're going to explore later on. Okay? Because it will be 2 times 2 times 2 to 3 times 3 times 3, which is 2 to 3 cubic. Same thing for example, a cylinder. Let's say we have a cylinder over here, and it is similar to a smaller cylinder. Similar. So let's say here I have 10. Let's say this is 5. Okay, the height 10 and 5. Then I give you the radius over here, this being 4. Radius. What do you think is the radius over here? Radius. How much is it? 2. You are right. What is the ratio of volume?
4 square.
Ratio of volume.
4 square times
Equals to 4 what?
square. 4 square.
How much? How much? What to what?
4 cube times 10.
4 cube to 2 cube.
Really?
Really, meh? Let's find out lah.
I thought times 10.
Okay, wait lah. Ratio of volume, right? What is the volume on top? The bigger volume. 4. Wait. Pi r square h. Right? Pi r square h. That's the volume for the bigger cone. Bigger cylinder. Volume for the smaller cylinder. Pi 2 square 5. Cancel. Let's cancel. Cancel. I will rewrite whatever is in the bracket to make it clearer for you. 4 over 2 square. 10 over 5. Agree? Okay, what is 4 over 2 equals to? 2 over 1, right? Square. So 2 over 1, right? So this becomes 2 over 1 square. Cube. And this gives me 8 over 1. Okay? Now, initially I told you that the answer is actually 4 over 2 cube. Right? Isn't this the same as 8 over 1? Yeah. What about if I choose to use 10 and 5? Will I get the same answer? Yeah, I will. I can choose to use the height if I like. I can choose to use the radius if I like to. I will still get the same answer because they are similar figures. What if somebody tries to be funny? One of the teachers, right, try and set you this type of question. What? Yeah, maybe it's me. I give you the circumference. Circumference equals to maybe 100. Then this one, circumference equals to 30. Then how? What do you mean same thing? Do you want to find the radius first? Can you find the radius?
Yes.
Can or not? You can, right?
By pi, then divide by the...
Yeah, but do you want to? No, you don't need to. You divide to get the radius, then you have the ratio. You are still going to get the same answer if you simply use 130 and you cube it. Because they are similar.
So you just cube.
Yeah, just cube. And then simplify. Okay? So we have covered 2 more already. 2 more topics. I'll continue the next lesson. Okay? Is it